In this video, I'm going to show you how to do IPv6 subnetting. IPv6 is a little bit of scary. It's not like IPv4 with regular decimal numbers that we can understand. IPv6 uses hexadecimal number that we normally don't use every day. That's why it's much difficult to fathom those numbers. Regardless, IPv6 is going to be the next generation internet protocol and its adoption is increasing faster. If we look at the overall traffic and network advertisements, over 25% of all internet connected networks advertise IPv6 connectivity. So you can tell this is going to increase further, not going to go down. So that means we all have to get familiarized with IPv6 like we did with IPv4. If we look at the IPv6, it has 8 groups of 4 hexadecimal digits. You see here 4 hexadecimal digits and a total of 8 groups separated by colons. And the first 3 is used for network parts. It's like IPv4. IPv4 has different classes and there is network digits and client digits. Likewise in here, it has network portion and subnet portion and client IDE portion. So let me go a little further and look at the IPv6 addressing. So there are 8 groups and each one is a hexadecimal digit. So here you have 4 hexadecimal digits and each hexadecimal digit has 4 binary bits. So that means one group is going to be 4 into 4, 16. And if you multiply 16 into 8, you come up with 128. So IPv6 is 128-bit long, not like IPv4, which is 32-bit long. So if you look at the chart, this is a hexadecimal chart. As I told you before, each hexadecimal digit is composed of 4 binary numbers. And it goes from 0 to 15, and this is a decimal number 0 to 15. So we are not going to use these decimal numbers. We are going to use the hexadecimal representation, and it goes from 0 up to 9 as same as a decimal, and then goes into A to F. That's what it makes a hexadecimal number. And these are the binary representation of these numbers. So if we look at here, 2, and 2 is, so these 4 numbers here, that is 0010, that represent 2, and you see here 0010, that is represent 2. And let me go back there, and so these are zeros, so all of them are going to be zeros, that means 8 zeros, and then 1. 1 is going to be 0001. So if you go here 1, that is 0001. So that's how you convert hexadecimal digit into binary bits. So you know how to convert all of them. So all these numbers came from the hexadecimal digits. And when you write these numbers, if you have all of them zeros, consecutive zeros in a group, you can represent by 2 colons. But you cannot use these 2 colons twice, because that will be problematic, because the algorithm know everything else come here after 0. But if you put 2 colons here, it's not going to know how many groups come here, how many groups come here. So you can use these 2 colons only once. And then you can remove these leading zeros. So that means you can write it in a different way. I'm going to get to that in another section here. So if you look at here, this is a unedited, unabbreviated IPv6 number. And then you can make all zeros into one zero, and you can write it down as it is here. There's nothing to abbreviate. And here you have 2 continuous groups of zeros. So you can represent this with 2 colons. So if you come to the final thing, so this come as it is, and you can represent this with a single zero, and you have to write it as it is. You can represent everything into 2 colons, and then you can remove this leading zero, and then you have to write this one as it is. So this is the abbreviated IPv6 number, because writing a long 128-bit is very cumbersome. So if you can abbreviate, you have to just put it this way. So let me go back here. So we looked at what is IPv6 here, and then we understand how we can write IPv6 addresses and how we can abbreviate. So now we get to the IPv6 subnetting part. Before we go into subnetting part, we need to know how to obtain IPv6 address. So if you are a regular customer, you can get the IPv6 address from your ISP. If you are a Charter or Verizon or AT&T customer, your ISP will provide you with an IPv6 address. But if you are an ISP or a large enterprise customer or a university or institution, you have to request a big block of IP address, because it's not like a customer, you just get one IP and you're done with it. They will need thousands and thousands of addresses for their large institution and the customers. So you have to request an IPv6 block from one of these organizations. So this is called Regional Internet Registry. So there will be 5 of them in a different region. So if you are in North America, you have to go ARI and ARIN. They are the one providing you the IPv6 address. So you have to contact and create a login with them, and then request a IPv6 block. If you already have an IPv4 allocation from them, it's pretty simple. The process would be pretty simple. Okay, so as I told you before, this is the first 3 is going to be the routing prefix, and this is for the subnet ID. So routing prefix can be said it's network, and this is for subnet, and this is for clients. So you will be getting the first 2 portion from the ARIN. That's if you are North America, these 2 will come from the ARIN. And then the third one is going to represent your region or your institution. So if you are a university, you can decide this part of it. So let me go to the block so you will understand it further. So block size. If you are a big, large institution, you will be provided with /32 address. So /32 means each block is 16. So 16 into 2, 32. So you will end up with only these 2, and you have to make up everything else from there. And if you are, if you have this many sites, next level is 36 block, and next level is 40, and 44, and 48. If you have one single site, you will be provided with a /48. Okay, so let's look at, I'm going to go here first. This is the IPv6 subnet cheat sheet. Let me go in there before I start the subnetting part of it. So if you see here, IPv6 subnet cheat sheet and IPv6 cheat sheet reference. This tells you, okay, how many IP address you will get if you use this CIDR number. So /28, you have just one. It's like a /32 in IPv4. And then if you go down to the path, it will be increasing. And then you come here, that will be 64 residential. So if a block is /64, let me tell you one thing here. So that means in IPv6 4, we have a concept is like you cannot use the first IP and last IP that is used for network and for the broadcast IP. But IPv6 is not like that. You can use all the IPs available. So if you get a /64, that means, let me go here and then I'll show you here. So this is where the /64 comes. So if you see like a 4 network part and subnet ID /64 here. So that means if you are getting a /64, you have only one network, one subnet. So that's why one site, that's why this is telling you a residential allocation /64. And other 64 all can be host. So you can have this many number of hosts in a /64 IP address, a block. And you go down here and then you come here, it's a business. If you are using a /48, it's going to be a business one. And if you this is 32, is going to be the ISP allocation. So if you are the Charter Communication or AT&T, Verizon, Aaron will be providing them with the /32 subnet. And that's the one you can get, the biggest one you can get from Aaron or any other internet registry. So let me go back here and I'm going to go to this calculator. This is where I'm going to do the calculation part of it. So for this, I'm going to grab an address here so I can show you how the allocation works. So this is the address I have been given by Aaron. So it's going to be 2 colons, and that's going to be 32. So you say if you are an ISP or a university, you will be provided with this block. So when you get this block, you put this one here, and you can go down here and find out how many smaller subnet you can create from this block. So if you have just 32 is just one subnet, and if you are going to create 2 subnets from this 32, that will be 33. So if you can go down here all the way, and that will be, tells you if you want the 60 subnets, you will be having a lot many subnets here. So the best idea in subnetting is if you are going to divide this 32, you have to follow this one. Let me show you this allocation typing. This allocation type. So for one site, think about you have a big site, you have a very big department or something. So say School of Engineering, you want to allocate them with the 48. So I will go here. So you have to start with, first you start with 40. That's the recommendation. From 32 go to 40. So you will have 256 40s. So that means you can allocate this one to 40 big entities within your organization. And then what you do is you take, so you have 256 40s. Say you have a big pie and you take the pie, cut into 40s first. So you will get 256 pieces. And then you take the first piece here, right? And then you cut that first piece. I would say take the first piece and cut that first piece. This is a 40 subnet. And you can create how many 44s? So you can create from 40 to 44. You can create 44, you can create 16 subnets of 44. And let me go to the block again. So 48 to 44. And then, so we are coming in this side. So it recommends 36 also. So you can do 36 before 40. So let me go here, 32, and you go to 36. So you have 16 36 subnets, and you take the first 36 and make it as 40s, and you can create another 16 40s, and you take the 40s and do 44, and you take the first one. That's not going to change here. They take the first one and create 44s. You have another 16 inside. And then you take that 44 and you create 48s. So you have another 16 here, right? And this one will give you so many addresses. So if you look at, so you take this 48 and divide this into 64 subnets. This is the recommended client subnet. So you take 64. So you have 65,536 client subnets you can create from 148. So think about how many subnets you already have. So if you go to the cheat sheet and if you look at here, you have a /64, right? You have a /64, 65,536 subnets, and each subnet can have this many hosts. So that's why IP version 6 is enormous, and you get trillion and trillions of addresses you can get. So let me look at how many client IP in IPv6. So let me, how many IP addresses does support? So it support this many, it's unbelievable. This is equal to 340 trillion IP addresses. So that's why they created this IP address never deplete like IPv4 address. Hope you liked this video. If so, please hit the like button below and subscribe. If you want to get notified when I release my next video, go ahead and turn on the notification bell. Thanks for watching and see you next time.